Practitioners in the healthcare industry are required to have experience examining organs, bones, skin, and all the other complexities of the human body to learn how it works. We were thrilled to know that the UBC Faculty of Medicine and the HIVE wanted us to build a virtual anatomy lab that provides this knowledge to students across the globe.
Welcome to the UBC Virtual Anatomy Lab.
We had to deconstruct a doctor's mind to understand what human anatomy is all about in order to organize the content for this application. We discovered that doctors need to observe specimens closely to understand how the body functions and when something is wrong with it. We studied several competitor products and found that digital platforms used artificially created 3D specimens. However, in order to show a more accurate representation of the human body, we used photogrammetry scans of real specimens provided by UBC and the HIVE. So we did initially consider building this application in virtual reality. However, after we conducted a user survey, only 4 out of 100 participants had access to a VR device, and every single one of them had easy access to a computer and internet. Our target audience preferred this platform because it was quick and easy to use, and it had a fairly large screen which made it easy to read text.
Based on our project requirement and further research, we found that many students cannot visit an anatomy lab in person to gain essential medical training. Our goal was to develop an immersive virtual anatomy lab where students can closely and respectfully inspect and compare multiple specimens. Our main priority was accessibility and creating an accurate representation of every single specimen on application.
To achieve our goals, we created 3 early concepts. The first one is a museum, where a user can walk around and observe different specimens in a museum setting. The second one is tray, where a user is immersed in a laboratory environment to inspect a specimen closely. The third one is gallery view, where a user can scroll through galleries of specimens and select them as per their body part. We combine all of our ideas and differentiated between the must-have features and nice-to-have features.
We designed the experience to be respectful, formal, and sit in a professional environment. This was reflected on both the sound and the visuals used in the application. In order to remind people of the ethical and the professional boundaries that they needed to respect, we made it mandatory for the official policy of the UBC Faculty of Medicine to be acknowledged. From an audio perspective, we created custom sound design inspired from the PA system at hospitals and clinics. We studied the steps and behavior of a doctor in a physical anatomy lab and how they would manipulate a specimen. To give people the same experience, we translate these findings into an immersive 3D virtual lab.
Our user experience and development decisions were driven by the following considerations: the time and effort required to develop each feature to a professional standard, our understanding of what a professional and respectful laboratory environment looks and feels like. This is an educational tool, not a game. The gross anatomy curriculum, which requires that users can view real donated specimens and analyze said specimens from all angles. The requirement for additional information to be displayed is annotations assigned to specimens. Students' needs for quick and easy access to class material. The HIVE's needs for easy updating for course content. In order to ensure long-term usability, we developed a custom API and a prototype of a 3D content management system to give the client the ability to add, remove, and edit specimens, annotations, and lab content without having to rebuild the application in Unity.
We conduct user tests with medical students from the UBC and received valuable technical feedback that was used to improve the usability of our application. We are proud to have finally achieved our goals. Students were given an experience that was close to a real anatomy lab. We hope our work will help train better doctors who will save lives.